Hi, in this video I'm going to show you the experiment 35.1, the determination of enthalpy change of formation of calcium oxide. Now first of all you need to know that in order to form calcium oxide we will have calcium reacting with oxygen. However, the direct reaction between calcium and oxygen is too vigorous and often it may form some side product such as calcium nitride. So a direct determination is not feasible. So that's why in today's experiment we will actually go for an indirect method. Actually, we want to perform two separate calorimetric experiments using calcium and hydrochloric acid as well as calcium oxide with hydrochloric acid. And from there, we are able to establish an energy cycle, and by establishing an energy cycle, we are able to determine the enthalpy change of formation of calcium oxide. Now, before I start the experiment, let's have a look at the theoretical background, especially how we can establish the energy cycle. Now, first of all, we need to know the thermochemical equation for the standard enthalpy change of formation of calcium oxide. Now, we are trying to improvise and construct an energy cycle. We will start from calcium and we will actually react it with hydrochloric acid. So here it reacts with hydrochloric acid. We need 2 moles of hydrochloric acid. So calcium reacts with hydrochloric acid to give us calcium chloride, hydrogen, okay? And you know that this half mole of O2 doesn't react, so it just stays unchanged like this, okay? Now, so for this reaction, we're actually going to perform a calorimetric experiment to find out the enthalpy change of reaction of this reaction. So let's just put delta H R A, right? So this is like enthalpy change of reaction A, all right? Now, the next thing that we are going to do is, from here, H2 gas and a half mole of O2 gas, actually, these two can react with each other to form 1 mole of water, okay? So these two here, they can react to form water, okay? And this one is actually the standard enthalpy change of formation of water. And this one you can easily find it from the data booklet or from the internet, okay? And of course, this one remain unreacted, so you can just copy it down here, okay? Now, going back to the top here, so calcium oxide is able to react with, again, hydrochloric acid. And as it reacts with hydrochloric acid, it will give us calcium chloride and water. So actually, this one complete the cycle, right? When you add 2 moles of hydrochloric acid, then it will give us calcium chloride and water. And this one, we will put it as delta HRB, all right? So it's another reaction, and we're actually going to perform a very similar calorimetric experiment to find out the enthalpy change of that reaction. So these two are experimentally determined, and basically this is the two that we are going to determine in the later on experiment. And from here, let's just put down, okay, delta H naught F CaO. This is the thing that we are looking for. So from this cycle, we are going to construct an equation. You can think about it as this one as the starting point and this one is the ending point. So from here to here, you can either go from this way or this way, right? So you can easily put down this one, delta H naught F CaO plus delta HRB equals to, so this one equals to this one, okay? Okay, so if you get this equation, you can rearrange the term, then you will have delta H naught F CaO equals to delta H naught Ra plus delta H naught F water minus delta H RB, right? And this one is from the data booklet, and these two are from your experimental results. Okay, then this is how you can find out the standard enthalpy change of formation of calcium oxide in an indirect method. Now let's go back to the experimental procedure and see how we can actually carry out the calorimetric experiment. So in the first part, we are going to carry out a calorimetric experiment to find out the enthalpy change of reaction, or the delta HRA, which is the reaction between calcium and hydrochloric acid. So the first step is we are going to measure around 1 gram of calcium metal. So first of all, we need to measure the mass of an empty watch glass. Record the mass of an empty watch glass. Now, add around 1 gram of the calcium granules. Record the mass of the watch glass and the calcium granule. After weighing the calcium granules, now we are going to prepare our calorimetric experiment setup. So the container containing the reaction mixture will be this polystyrene cup. And we are going to add this one into a beaker containing the cotton wool. So that should do it. We are going to transfer 100 cm cube of 1M hydrochloric acid. And we're going to transfer that into the polystyrene cup. Now, we will have a lid with 2 holes, and with the middle hole, we are going to insert the thermometer. And with a smaller hole, we are going to insert a stirrer. And then we are going to cover the polystyrene cup with the lid. Monitor the hydrochloric acid until you get a constant temperature. So record the initial temperature. Now, open the lid and carefully transfer all the calcium granules into the acid. Close the lid quickly after transferring the solid, and then using the stirrer to gently stir the mixture. The temperature should be increasing as the reaction between calcium and hydrochloric acid is exothermic. Monitor the temperature rise until you register the maximum temperature. Alright, I think it has reached its maximum temperature. So record the maximum temperature. Set up to have a look at the mixture. Now, you may see that there are some grayish solid remain undissolved. So that means there could be some impurities or some other chemical substance that is involved in the calcium granules. So that may account for some errors in your experimental results. Now, after the experiment, make sure you also measure the watch glass because we want to find out the actual mass of calcium granule that is added into the polystyrene cup. There might be some calcium granule bits that is left on the watch glass. So let's measure it for the last time. And then we are going to do a very similar experiment, but this time with calcium oxide. Now we need to measure the mass of calcium oxide. We will measure around 1 gram of calcium oxide. Similar to our previous part, first we need to measure the mass of a watch glass. Record the mass of the watch glass. Now add around 1 gram of calcium oxide. Record the mass of the watch glass as well as the calcium oxide. With a new empty polystyrene cup, we are going to put it into a beaker with the cotton wool. Measure 100 ml of 1M hydrochloric acid using a measuring cylinder. Transfer the hydrochloric acid into the polystyrene cup. With a new lid and a new thermometer, insert the thermometer into the lid. And with the stirrer, insert it into another hole of the lid. Cover the polystyrene cup with the lid. Allow the setup to stand for a while until you register a constant initial temperature. Record the initial temperature. Open the lid. And quickly transfer all the calcium oxide into the polystyrene cup. Cover the lid and stir gently with the stirrer. So record the final temperature registered from this experiment. Now measure the watch glass after we transfer the calcium oxide to see how much calcium oxide do we actually transfer to the expanded polystyrene cup. So that's it for the experimental part. Now we will proceed to the calculation. Alright, so after we finish the experimental part, then we are using the experimental data to do some calculations and at the end to determine the enthalpy change of formation of calcium oxide. So first of all, in part A, the reaction between calcium and hydrochloric acid. So we do Q equals to mc delta T. So for mass, we are going to put down 100 gram because we add 100 cm cube of hydrochloric acid. So as we assume that we are heating up 100 cm cube of pure water. For C, here we will use 4.18. For delta T, what we have registered is 27.4. So you will tap your calculator. So you will have 11.4532 kilojoule. After that, we are going to look into the delta H. And in this case, this is the delta H RA because it is the part A. And this one equals to Q over the number of mole. So here, the number of mole will be determined by the mass of calcium that you have added. Now here, we need to know that the calcium added is the limiting reagent. You can tell that by simply doing some mole calculations, or you can tell by the fact that after the reaction, you don't see any calcium left. And that should be very obvious. Now, so the number of mole here equals to mass over molar mass. So the mass of calcium that we have added is 1.008 gram divided by the molar mass. For calcium, it is 40.1. Then you tap your calculator. You will have, now this one, because it is exothermic, so you need to add negative here. So at the end, you should get negative 455.6282937. We will take three significant figures, so you will have negative 456 kilojoule per mole. Okay. Now moving on to part B. So we basically do similar calculations. So here I'm going to speed up. So after that, we are able to calculate the delta HRA, delta HRB, as well as from literature value or from the data booklet, we are able to find the delta H0F water, which is this one. Then using these three values, we can simply plug it into this equation. This is what we get before we perform the experiment. So now we can just plug in all those values. So this is what you have. So that's it for the calculation, and this is also the end of the video.